Hey guys, welcome back to my CCNA 200-301 course. In this video, we'll continue our wireless journey with Cisco wireless networks. Are you ready? Let's get started. In enterprise network, at the end of the day, we have to connect our wireless gears to a wired network. Cisco has a famous three-layer switching architecture. At the bottommost layer, we have our access layer switches, which our endpoints are normally connecting to the access layer switches. Access layer switches are getting connected to each other through distribution layer switches, and distribution layer switches are getting connected to each other through core layer switches. And when we go up towards this hierarchy, the processing power of these switches are getting better or higher and higher. So we have our most powerful switches at core layer because they have to process a lot of traffic that are coming from different directions. In some situations, we can combine core layer and distribution layer, and we call it collapsed core or core collapsed, where we have only one layer on top of access layer, and we normally call it core layer in that situation. Anyway, our wireless access points or WAPs normally connecting to the access layer switches, and from there they provide wireless connectivity to our wireless devices like our phones, computers, tablets, or whatsoever. Now let's talk about Cisco wireless architecture. The first architecture we want to talk about it is called autonomous. Basically, to provide a wireless connectivity, we have two sets of functions: management functions and operational functions. For management functions, we can name something like authentication, association, and reassociation of the endpoints. And for operational functions or real-time functions, we have like beacon frame, transmissions, encryption, and etc. In autonomous mode, your wireless access point, which is something like this, is able to do both of these sets of functions. So we run an image on this access point that is capable of doing all of these functions. And this access point would be able to provide wireless connectivity independently from rest of the network. The only thing you need to do is connecting this access point through its Ethernet interface to your access layer switches, and then configure this access point, or first configure it through the console port and then connect it. It doesn't matter. Anyway, you have to configure it through the console port and then connect it through to the network. So the first thing is connecting your laptop to the WAP and configure it. If you are in a big network or enterprise level network, we may have like 200 access points or even more. So in that case, Cisco developed some software for you to help you with this cumbersome work. So you can use applications like Cisco Prime Infrastructure or Cisco DNA Center to configure these WAPs. But at the end of the day, these WAPs will operate individually and independently. There are some caveats with this setup. First is, with this setup, we will have BSS or basic service set. So each of these WAPs will operate individually. So you need to configure channels, for example, on these WAPs. So you need to know where do you install this WAP, who are the neighbors, so you can configure the proper channels on each of these access points to avoid any sort of interference or overlapping between the channels. Roaming is not going to be very smooth with this setup because these access points, as I mentioned, are acting or operating individually. So when your user connecting to this WAP, and when it roams or moves in the office towards the other WAP, it has to disassociate from this one and associate to the other one, which provides interruption for the computer, which is not good. The second architecture that we want to talk about it is called split MAC or controller based. So as the name shows, we have a controller here, which is called WLC or wireless LAN controller. A wireless LAN controller is a device like this. This is the front side and this is the rear side where all of the connectivity is happening. So this is an old wireless LAN controller, 2100 series, which was running Air OS as their operating system. But the ones that you can see in the slide are one of the recent wireless LAN controllers that Cisco introduced, and they are 9800s. These wireless LAN controllers are running iOS XE, which makes them a good candidate for automation and software-defined networking. Anyway, in a split MAC mode, we actually divided the MAC layer functions or splitted them between WLC and the WAP. And the WLC is taking care of management functions, and the WAPs are taking care of operational functions or real-time functions. So these WAPs do not need that huge image, they need it in the autonomous mode. And that image is called lightweight. So we're running lightweight image on these WAPs and we call them LWAPs, lightweight wireless access points. Now we needed a protocol or something that can help us to make wireless LAN controller talk to LWAP and control it and provision it and tell it which channel you should work on, etc., etc. That protocol is called CAP-WAP, or Control and Provisioning Wireless Access Point. And that CAP-WAP has two different tunnels. One tunnel is for data and one tunnel is for controller-based stuff or control-based stuff. And CAP-WAP has been introduced in different RFCs. CAP-WAP is a tunnel that is happening between wireless LAN controller and LWAP, and within that tunnel, controller control and provision wireless access point, and also the wireless data is transferring through that CAP-WAP tunnel. This CAP-WAP tunnel provides a very good thing for you in the networks. Because it's a tunnel that is running between the two and that is running in layer 3 actually, these two devices, I mean WLC and WAPs, do not need to be in the same layer 2 network. So wireless LAN controller can be somewhere else, and the WAPs can be somewhere else. I mean in terms of IP networks. So they just need IP connectivity to be able to talk to each other. And the last thing I want to talk about, mention actually for this thing is wireless LAN controller necessarily is not a separate device. Cisco has introduced many switches like 850s and also 9K switches that are capable of having a built-in wireless LAN controller. So this wireless LAN controller can be a separate device, or the functions can be built into some switches. So you need to check based on your requirements, number of WAPs, capabilities, etc. You can look for a separate wireless LAN controller in your network, or buy some switches that are wireless LAN controller capabilities built in. You can configure your WAPs in different modes or kind of different roles within WLC. The default mode is called local, which is what you expect from a normal WAP to provide connectivity to the wireless networks, etc. But you can put your WAP in other modes as well. So for example, in Flex Connect, your wireless access point would be able to provide between SSID connectivities. I mean, if one computer is connected to SSID A and the other computer is connected to SSID B, even if the CAP-WAP tunnel is down, the access point in Flex Connect mode would be able to provide connectivity between the clients that are connected to different SSIDs. In sniffer mode, as the name shows, your access point operates as a sniffer and grabs or fetch all of the packets in the wireless networks, so around it. So you can use a packet capture application like Wireshark to grab all of your data that is going around in your network, to be able to, like, for example, give it to an IDS system to detect any sort of anomalies or even like attacks, etc. Rogue detector, as the name shows, can help you to detect the rogue devices in your network. Basically, how it works is checking the MAC address of the wireless devices and also the wired one, and if there is any MAC address that is existing in both ends, wired and wireless, it will be detected as a rogue. In breach mode, you can connect two separate networks that are distant from each other. This mode is normally, we use this mode to provide connectivity between two different buildings. For example, we have building 1 and building 2, and there is no any like normal cable based connectivity available in that area. So normally we put some access points above the buildings to provide wireless connectivity between these two buildings, and they are normally outdoor access points that can help us, or radios that can help us to provide this type of connectivity. But even in the indoors you can do that and provide two separate parts of your network to be able to connect through this wireless access points. It works like a wire between two separate networks. Flex and Breach is the combination of Flex Connect and Breach. SE Connect is helping you to do a spectrum analysis. So if there is any kind of interference in your network, you can use SE Connect mode to help you with that. And Monitor, as the name shows, put the access point in Monitor. So it doesn't transmit anything, it just receives the signals and data that is going around, and can help you with some security IDS type works or detecting rogue access points, etc. The last but not least architecture, which is my favorite as well, is called cloud-based. In cloud-based, the controller is moved to the cloud, so you don't need to have an on-prem controller to manage your wireless networks. In 2014, Cisco bought a company called Meraki, and Meraki is actually having all of its management stuff into the cloud. So to be able to manage your wireless networks, you just need to open a web browser in your computer and connecting to Meraki dashboard. And the Meraki access points are like this one. This is an MR33, and like other access points, you connect this WAP to your network. And then the only thing is this requires internet access. So if you give it an IP address, and then through that IP address, this WAP needs to be able to access internet to connect to that cloud-based controller and fetch its configuration from that controller that is in cloud. The thing is, Meraki devices are not only WAPs, so Meraki has other devices as well, like routers, firewalls, and switches. So we can manage all the stack in the Meraki dashboard. And recently also Cisco moved them, provides this capability to manage 9K switches and also 9800 wireless LAN controllers in the Meraki dashboard. Before finishing today's video, we have to talk about one last thing, and that is the mode of this interface in terms of being access or trunk. You remember that when we talked about the VLAN stuff, and we said if you want to send multiple VLAN traffic over a link, that link needs to be in trunk mode. But what is that situation now with these three different architectures that we talked about? Within these three, two of them actually, this link needs to be in trunk mode. For Meraki, and also when your access point is in autonomous mode. So, because the reason is, these are kind of individuals, and if you have multiple SSIDs that are going through different VLANs, for example VLAN 1 and VLAN 2, this link needs to be trunk to be able to provide connectivity and also keep the segregation between the VLANs. Okay, but for WLC based or controller based, because we have a controller here, and there is a cap web tunnel between this and between the wireless access point and the controller. Everything is going through a tunnel. So this link can be in access mode. And normally it is for the management VLAN of that WAP. So bear this in mind as well. Alright guys, this was our today's video. In the next video, we'll be talking about wireless security. I wish you enjoyed today's video and see you in the next one.